Hey everyone, Kathryn here. We're going to do a little bit from Unit 6, and that's the 6 trig functions. Let's look at our first example. Find the 6 trigonometric function values of the right triangle. Simplify your answer, including any radicals. Use integers or fractions for any numbers in the expression. All right, so we have our first one here. We have a right triangle. That's important to find our trig functions. And what's even nicer is we don't have to use the Pythagorean theorem to figure anything out. It's all right there. All right, so let's see what we have. We have this guy. That is a Greek letter. It's called theta. And compared to theta, this is going to be my adjacent, ADJ. All right. The opposite is here. It's kind of opposite of theta. We have OPP. And then we also have the hypotenuse. To find the hypotenuse, it's pretty cool. Well, first of all, we know that the hypotenuse is the longest side. So it's the biggest number, right? But if it wasn't there, all I have to do is look at my little square here, and it's almost like it's pointing to the hypotenuse. So this is our hypotenuse, HYP. Now we are being asked to find the 6 trigonometric, now you try saying that, trigonometric functions. And those are sine, cosine, tangent, secant, cosecant, and cotangent. Now you're probably thinking, how do I find those? What is this? Let's look at sine first. So the sine of theta is always going to be the opposite over the hypotenuse. Then the cosine of theta will be the adjacent over the hypotenuse. And finally, the tangent of theta is the opposite over the adjacent. Now for the secant, cosecant, and cotangent, it's actually really crazy from here. I shouldn't say crazy, easy. So the secant is just 1 over the sine. Well, our sine is opposite over hypotenuse, so the secant is hypotenuse over opposite. The next one is the cosecant of theta. Now, can you guess what that's going to be? Yeah, it's going to be 1 over the cosine of theta, which is just the hypotenuse over adjacent. And finally, make myself a little bit more room here. We have the cotangent of theta, and that's 1 over the tangent of theta, and that's going to be the adjacent over the opposite. Now, some of you might be thinking, oh my gosh, how am I supposed to memorize all this? Have you ever heard of SOHCAHTOA? That's how I remember it, SOHCAHTOA. And how do we get that? Well, I have sine, opposite, hypotenuse. So we have cosine, adjacent, and hypotenuse, ka. And then we have the tangent, opposite, adjacent, toa. SOHCAHTOA. Yeah, pretty cool, huh? Now you might be wondering, well, what about the secant, cosecant, cotangent? Well, if you have this memorized, it's not too hard to get those because it's just 1 over those. Now that we have that under control, let's start answering our questions. Sine. Well, sine is the opposite over the hypotenuse. Now we're looking at our theta. We're looking at this angle. What is the opposite? Well, the opposite is 7. And what's our hypotenuse? 25. And that's it. Yeah, it's kind of crazy. Since we did the sine, we might as well do the secant at the same time. It's just the reciprocal, the flip, 25 over 7. Okay? Let's look at the cosine. Now, the cosine is the adjacent over the hypotenuse. Now, remember, we're looking at our theta. Our adjacent is 24, and our hypotenuse is 25. So what's the cosecant? Just flip it. Find the reciprocal. 25 over 24. The last one, The tangent of theta, well, the tangent of theta is opposite, which is 7, over adjacent, which is 24. And that's it. Oh, and then of course the cotangent. That would be 24 over 7. And you did it. Not too bad, huh? I'm glad you said it wasn't too bad, because guess what? You get to try this one by yourself. Pause the video, do it, and then press play for us to work it together. All right, let's see how you did. Now, hopefully you didn't freak out because the theta is over here this time, because it's the same rules. Right next door is our adjacent, ADJ. Over here is our opposite, OPP. And then, of course, the hypotenuse is the longest side, but also our square points to it. So this is the hypotenuse. Now let's start answering our trig functions. Now let's remember, SOHCAHTOA. So the sine is opposite over hypotenuse. What's the opposite? 8. What's the hypotenuse? 17. Then cosine is ka. So that's adjacent over hypotenuse. Now our adjacent is 15. Our hypotenuse is 17. And then TOA is our tangent. And OA, that is the opposite, which is 8, over the adjacent, which is 15. Okay, cool. Some of you might have done the sine and done the secant right away. No biggie. That will be 17 over 8 because it's just the reciprocal or the flip of the sine. The cosecant is just the flip of the cosine. And then the cotangent, guess what? Yeah, is just the flip of the tangent. And I didn't mention before, but if any of these can reduce, you want to reduce them also. And that's it. SOHCAHTOA. How cool is that?